Startuprad.io, your podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody. This is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany, as well as the world's #1 tech internet talk radio station called Startup.radio. Wherever you're listening to this or watching this, make sure to hit the like and subscribe button. Today, I'm very excited to have Angela here with me. Hey, bom dia.
Bom dia. Oh, you speak Portuguese.
A few words. You are, as people can already tell, from Portugal, but you do have a very interesting story. And you were actually here because you're part of our series in the winners of the German Startup Awards. You won the German Startup Award 2024 Newcomer of the Year. Congratulations.
Well, thank you very much.
Not only are you an entrepreneur, I would say in medtech. Would you agree? Medtech?
Yes, medtech fits quite nice.
Yes. You're also a professor, which is very, very exciting and interesting. So let's get a little bit done here. Before that, I would like to thank our sponsor, Startup Raven, the easiest and most efficient way to find new cooperation partners and potential investors. Link down here in the show notes. You can register for early access. As we said, Angela, you are doing a medtech, but what totally confused me when I looked through your CV on LinkedIn, you studied first physics. How did you end up with a medtech startup?
Oh, well, that is actually quite logic. It fits totally well.
Oh, please take us along the journey.
Absolutely. So, and it's not just physics. It's physics, technological physics engineering. That's the name. So I'm an engineer by background. But the physics course includes, or the physics studies, it always includes quite a strong part in biophysics, medical physics, radiation physics, this kind of things, which you connect quite well to medicine. Basically, you cannot do medicine without physics, I would say.
One question before we proceed with that. You're an engineer. Are you still running around your house and fixing stuff?
I actually do. And I also install my own lamps and all this kind of things. And I really like to do this stuff. So yes.
Are you such a Raspberry Pi and open source fan?
That maybe not so much. But I like playing around with things that I can assemble.
Okay, I see. Yeah, typical engineer. You went there to postgraduate program in biophysics and biomedical engineering. You got a PhD from Lisboa in biomedical science and molecular and cellular biology. I actually have no clue what you did there at all. Maybe you can take us through there.
Yes.
And you also been working at the European Molecular Biology Laboratory, and you did your postdoc and later led a research group in lovely Berlin at Charité.
That is correct.
That's already a lot of stuff.
You
and
want me to summarize all that now?
But take us through the journey. Why did you do that?
Okay, so kind of quickly through it.
And everybody who's watching this, I'm sorry I'm sweating here. We are actually recording this in the hottest day during August. So I have 30 plus degrees Celsius here in my little office. I'm really sorry when I'm sweating here. Sorry, Angela, go ahead.
That's okay. So Hamburg is quite pleasant. You may want to come here. Not so hot.
I have it on my to-do list.
So I always liked the sciences. And therefore, when I was in high school, it was more the decision, do I want to go for physics or do I want to go for medicine? But I thought I could put both of them together. And the easiest way to do it would be first to go for physics and then to go for medicine. That was my initial plan. Yes, don't look like that. It was my plan. I changed my mind then, but I still studied a lot of medical related things while I was doing the physics. And I went to the EMBL, which you talked about. And that's where I did my where I did my doctoral work. So that's the PhD. It's a joint PhD between Lisbon and the EMBL. It was actually the first joint PhD that that they did between the University of Lisbon and the MBL. And so why the MBL? So for the ones of you potentially wanting to do a doctor or a PhD, the MBL is a European organization, a European institute, which has several outstations. I went to the one in Heidelberg, but it's Europe. It's not German. It's quite a big difference. So you speak English there. I couldn't speak a word of German when I went there. And they are very flexible in the way they think about things. So they are very open to have a physicist who has never entered the lab going there to an experimental lab and doing real experiments. And this is what I wanted to do. So that's why I went there. So I could apply some of the stuff that I knew from my engineering and my physics, but I could learn a lot of new stuff. And I started there the cancer research, which I had already been doing in the physics. But I was more in the field of radiotherapy and radiation and this kind of stuff. And then I went more into the molecular biology. And this you can connect. So you cannot stay for the rest of your life at the MBL. I don't know if I would have stayed if I could or not. So it's a wonderful place, but it's sort like a rotation place. So they want to give the opportunity to as many people as possible to pass by. So you go there, you stay 3-4 years, and then you should go somewhere else. So I went to Berlin. Why not? I mean, it's a nice city as well, but it did. It felt like a different planet, even though it was the same country, because you are at the MBL and you are kind of in a bubble, and you speak English all the time, and you know everyone, and all of a sudden you go to Berlin, and then you are in Germany. And it's a different experience, a fantastic experience, but a different experience. And that's where I then became also a group leader at the Charité Medical University.
We may add that Heidelberg is a very, very nice, lovely small city,
Oh, it's beautiful.
with a lot of very old buildings, from a castle and so on and so forth,
Very
as well as one
romantic.
of the world's oldest universities there. Yeah, very lovely, very nice place to
Absolutely.
visit. You can go down here in the show notes. I'll link the Wikipedia article to them. Actually, it's a place I also like to visit. It's not too far away from here. And
You
actually,
used to say you lose your heart in Heidelberg. So I got married there. Maybe that's the proof.
I didn't get married there, but my godchild lives close by. So that is basically the thing you did. Then you came to Berlin, and at what point did you decide to spin off your
The
knowledge, your
company.
know-how into company? And you also do have a co-founder. Where did you meet him?
Well, that took some time. So I came to Berlin in 2007, and I first was still fighting with the thought of, do I really want to start a group in academia? So you may know that an academic career is not the easiest thing to do. There is no guarantees of anything, and you jump from one place to the other always after the next grant and this kind of things. But I mean, it is still exciting, and the research is amazing. So it's quite a luxus. And I decided first I want to be a group leader, and that's what I did. I did it for quite some time, and that's where the entire or the science and the ideas behind the company was developed. So then what was really key was that the university and several universities have this kind of programs these days. So the Charité had first a program called Inventors for Health, where you just need an idea. You don't need to prove anything. You have an idea, and they make a sort of a boot camp. You go there, you discuss this idea, and you see if you convince people about your idea. If yes, then you get some funding to indeed try to show the idea has something on it. So this was the first thing that I got at the Charité. And after this, they had a different program called Digital Health Accelerator, and they really give you very large amounts of funding. You can get up to 1 million, and then you can really develop something. And that's how we developed the entire thing around our company, not just then the technology, but also the bureaucratic things connected to certifications and this and that. And that's where I got to know my co-founder.
I see. And then, did you hit it off quite well? And actually, my understanding right now is you are applying the research you did with the company. Was there also a part that your co-founder put in the company?
So my company has three elements, so to say. So the one is the university itself. It's part of the company, then me and the co-founder as well. So the expertise of this colleague of mine, his name is Benjamin. So the expertise of Benjamin is also from a scientific background, also has a PhD, but he had expertise in certification of medical products, which I didn't have. So this was really good. So that was the part where he came in. So not to develop the product per se and its technology, but to develop the way, how do you make this product as a medical product in all its legal aspects acceptable.
And we may add for our audience that you just simply cannot offer any medical product, as they can already assume you have to go through a certification.
Absolutely.
Yes.
Yeah.
And that is where the expertise of your co-founder lies.
Exactly. And you also cannot just do this kind of stuff from a university group. So you do need to start a company. So that was my motivation to start a company, because at some point, you reach the stage where you have the product and you have the impression this could work and this can help a lot of people, but you are bound to the persons that you have within the clinical studies where you do your research, and you would like to go broader and to reach more people. And for this, you need to get a medical product, and for this, you need to start a company. Yeah.
I see. Now, we've been talking a little bit about how you started your company, how you met your co-founder, and now everybody would be interesting for what you did get the German Startup Award. Let me quickly tell this. This interview is a media partnership with the German Startup Association, Bundesverband Deutscher Startups. Their German Startup Awards GSA 24 honor each year outstanding female and male founders and investors in special categories. You can learn more about them down here in our show notes. That said, you are the newcomer of the year, and with what idea did you start here? We already know it's from your research, and I've gotten it is related to your inner clock.
That is correct. So it's related to the system that makes time inside all of us. And what we came to the conclusion, or what we wanted to use, was to have this basic idea, which is like this. If your body has certain times to do certain things, your body also has best times to take certain medicines. And if you take these medicines at this optimal times of the day, then you will have less side effects and you will benefit more from the medicines. And now you would think, okay, what kind of a disease would benefit a lot from an approach like this? What kind of a disease has massive side effects and would benefit from more efficacy? And such a disease is cancer, because it's one of the treatments, the anti-cancer treatments, where side effects can be so high that sometimes patients, they can't be treated because of the side effects, not because it wouldn't work. So there you really need more things. You need something new. And that's what we wanted to do and what we are doing.
So let me try to keep this pretty simple. Your startup TimeTeller helps cancer patients to get their medication at the optimal time according to their inner clock.
We measure which time that is. So TimeTeller is a diagnosis. It's a so-called in vitro diagnosis that measures your clock, and based on that says this is for you and for this treatment the best time to take the treatment, but not which treatment you should take. So it's different, right?
Yes. But I do assume we mostly talk about drug treatments, either medication you can intake anywhere or you get an IV or something like this. Is that true? Or does it also apply to something like radiation therapy?
So I am not yet doing anything with radiation therapy, but yes, it would also apply to radiation therapy. So there are studies with radiotherapy where it was shown that depending on the time of the day when it is given, patients react quite differently and they cope better with the therapy or not. So you can pretty much apply this to anything actually, and not just to cancer. Imagine you are adding a new dimension, which is a dimension time, so a new complexity, and we just cannot ignore it.
Can you tell us a little bit about this circadian rhythm? I have one example here for me. I'm the person who stays up pretty late. You can usually find me working at 10 p.m., 22 o'clock in the evening. That's the best time. Everything's quiet. I'm highly focused. Everything is awesome. And then I will usually like to sleep in at least until 10 the next morning. But my wife is, she's completely different. She loves to get up early. Would that be an example of different circadian rhythms?
So
And can you tell us why those people always end up together?
I guess because they love each other, and because on that respect, you probably found a time where you are both awake at the same time. But apart from that, that should not be a reason how to pick up your partner. So yes, we have this internal rhythms, and this internal rhythms, they are dictated by our genes. So it's really not hocus pocus kind of stuff. It's true science. There has been already a Nobel Prize for it, and this was already 2017. But the important thing here is that we know quite well that these 24 hours exist, but they are different for each of us. So assuming we don't force the rhythm. So imagine that you are actually waking up early because you always have an alarm clock. Then that's probably not your real rhythm. That's the rhythm of your clock, your alarm clock. So, but assuming you wouldn't use any of that and you still wake up quite early or quite late, or you like to work earlier or late, that's very likely strongly connected to your rhythm, and it makes a difference. Now, the example you even gave with you and your wife, without wanting to put too much cliche here, but there are some groups, and for example, females, they tend to have earlier phenotypes than males. So they tend to have a tendency to wake up earlier, to go to bed earlier, and males somehow a bit shifted. So this, of course, doesn't apply to everybody. This also changes when we get older. So if you have kids at home, or people that have kids at home, you will know that babies, they probably don't have the same rhythm as their parents, right? So it's a problem. It drives us crazy in the beginning, right? We want to sleep, they don't, this kind of stuff. So
They don't have like any rhythm at all. For them is day and night exactly the same.
yeah, kind of. So their problem is they are not yet synchronized with the outside world. So we have a rhythm that runs per se. So even if you are locked inside the room, you have no clue what time it is, and you have no daylight, you still wake up and go to bed every day. So it's not that people, sometimes I ask my students, so are you convinced if you don't have an alarm clock, you would never wake up? Of course, some will say yes, but that's not true. They would wake up anyway because they have this internal clock. But sometimes it's not synchronized with the outside world. And this happens to the babies. So you need to give them a certain time, then they get synchronized and they are fine again. Then when you get teenagers, you run again a bit into a problem. So they get shifted.
What problem?
No, it's not a problem. Let's call it a challenge. It's a challenge because they get a bit shifted. So they tend to wake up later, go to bed later. Yeah. Of course, they don't help the situation because they like to play around with the handies a lot and this kind of things. That will not help. The more light your eyes get, the less you would like to go to sleep. So that's counterproductive. But anyway, so that also goes away at some point in your early 20s when you become a grown up. And then you continue, and through your life, your clock will change again and again and again, just like our faces also change. But you still have your very own rhythm, which is different from the rhythm of your wife.
Are there like clusters, groups, or types of people who do have a certain circadian rhythm? I know, for example, that there's one type called, for people who like to stay up late, they're called owls. Or do you have a lot more of those types, and how does it then again tuck into the cancer treatment we've been talking about?
So you basically have a continuous spectrum of all possibilities, but still the average or the largest group of the population will have what fits to our normal society, yeah, which is somewhere in the middle. Then you have a group that is the very early group, which you call the larks, and then you have the alls, as you said, the later group. And then you could think about many other animals in between, but I mean, that's not
I
really
would be
so.
something that is active at night.
Yeah, so I also
The
like
bat.
to work maybe. No, you are more like the all then. That's what you call it. I also like to work at night, but you have pretty much everything. But these groups, they are typically found by doing questionnaires. So there are different sorts of questionnaires. You can find them in the internet. So you fill it in, and then it tells you you belong to this group, whatever. But that's very subjective, as you may imagine. And what we realize, if we give this to people in our studies, sometimes people reply to these questions not with the truth, but with what they think they would like to be. So that's very funny. Yeah. And then they ended up with a profile that is totally opposite to what they really do, because just they think they would be better. For some reason, everybody thinks it should be good to wake up early. Yeah, I don't know why, but okay. So, but what we do in the connection to the cancer is we want to find out exactly the profile or the clock of these people. But for us, it's not enough to know if they are just early or just late. We need to go more precise than that. So we measure their genes. And their genes, when we measure them, it gives us a curve. It's like a wave. Yeah. And with this wave, we see different things. We see when the first peak of the wave comes, and we see how high that peak is. So the amplitude of this wave. And with this, we can calculate certain things.
And let me try to dumb this down a little bit. This wave is kind of when your body gets active, when your body wakes up from hibernation or something.
This wave is a 24-hour repetitive wave, which has a high and a low, and that's your circadian rhythm. So it's called actually circadian. Circa means about, and dies comes from dian comes from dias, which is a day. So it's a rhythm that is about a day. So we have other rhythms in our body, but this particular rhythm is our 24 hours rhythm. And so you can always measure your genes are pretty much, not all of them, but the majority. They're pretty much going up and down, up and down, up and down in their activity. So they are more active, less active, more active, less active. And they are involved in different processes. For example, your immune system. So that means you have times of the day when your immune system is more active or less active, which is also the reason why you have time of the days where you react with more allergic to certain things, or times of the day where you are more likely to get a cold or less because your immune system was more prepared for that. The same happens to your metabolism and all this kind of things. So you also
I
have best
see.
time for sports, if you will.
That is all quite interesting and fascinating. I would be curious. I just have a wave with a peak and a valley that is now in my
Pretty
mind
much,
in
yes. Yeah.
terms of 24 hours activity of my genes, of my immune system, my whole body, my circadian rhythm. And I would be interested in a few questions here. When is the best time to give those cancer medications, and when would be the best time to work out? Meaning, is it all on the peak or in the valley?
You cannot say it like that. So for the cancer medications, it depends on the medication. So we really need to know, and we don't need to know what type of cancer a person has. We need to know which medication the person is taking. And then we need to know what this medication does to your body. And only then we could say that is the best time. So my mathematical equations, they wouldn't do anything with the word medication. They would need to know exactly how this medication works, and then could do something with the circadian rhythm and the medication. So it's not new knowledge in terms of what is already being doing in research and what is already being doing by pharma companies when they develop a new medication. They, of course, know quite well how it works. The new knowledge is that we typically consider what something is doing, but not when. And now we say, but it's also important when. So it's just this factor when that we bring in. The rest of the knowledge has to be already there. If this was clear somehow.
Yeah. And for the sports, is it best when you're most active or when you're least active?
So for the sports, it's mostly, it will depend on which sports. So what we do is we typically split people at the moment in things which is more like endurance or strength or so. For most people, it is better to do endurance, so jogging if you want, rather in the late afternoon, not at 6 in the morning. So that's very common, right? So like go jogging in the morning. It might fit some people, but for most of them, it's rather go jogging at 6 in the afternoon. Yeah. So it tends to be better. Strength training, this rather tends to be better in the morning. And they relate in opposite ways to these peaks of these genes that we measure. But we do measure specific genes depending on the question we are asking. So if we are asking the question about sports, we measure this wave for a specific set of genes. If it's about treatment, we take another set of genes and so on.
This circadian rhythm, is it also already formed when you have a kid like 4 or 5 years old, or does it form over your adulthood? As you said, they're kind of shifting. And it's one of the many problems when you have a teenager at home.
You have a teenager?
No, not yet.
So you have these genes from the beginning on. And what they don't have, but this is not anymore the 4 years old, they typically have a nice rhythm already, but rather just the babies. So even though these genes and this clock, it works anyway without external signals, there is a very powerful external signal, which is light. So light is extremely, extremely important for us because it gives us every day a sort of a reset signal. Yeah. So, and this makes us be in time or makes us fit the outside world. Now, in principle, humans are day active animals. So we get the light signals in the morning, maybe, and then we stop receiving the light signals the more we go to the late evening or to the night, and then we sleep. And this stays, and this helps us to stay synchronized with our world. For the teenagers, this is the only time when really the shift is too strong, and this is because of the entire hormonal disbalance that at some point happens there, and they need some time, but then they are fine again. Which means if you start getting a lot of light in the middle of the night, then you shift your rhythms, and you are doing it then basically on purpose, and you shift them later.
When you work late, for example, like me in front of screens at 10, 11 in the evening, that is basically shifting my circadian rhythm by myself.
Yes,
okay.
You will do that. Yeah.
And it also means when you start fumbling around, playing around with your cell phone, replying to WhatsApp messages when kids are in bed, that also will shift your circadian rhythm later.
Yeah. Yes. And it will likely result in you having more troubles to fall asleep. But I mean, it's like everything in science always. So you have something which happens, it happens the most, but it doesn't happen to everyone. So I'm sure there are a lot of people that will do this and they will still sleep like a stone.
I see. And now the question is, what do you do with the company there? You're talking about gene analytics. So I would assume what your company does is drawing a little amount of blood, putting into a very big machine and analyzing like I wouldn't say a handful of genes, but a few hundred, and then you kind of get an idea at your circadian rhythm. Would that be
actually, it's much better than that. We don't take blood. Okay. We take saliva. You have to spit. So it doesn't hurt. That's very good. But you need to spit 4 times a day because we need this wave. And if you just do it once, we are not precise enough. And we don't need to measure hundreds of genes. We just need a few. And that depends on the application, maybe less than 10.
Okay, I see. And then basically the spit goes into your analytics machines.
It goes to the machine, yeah.
Yeah. Any company, is it producing the machine or just the algorithms to analyze it?
No, so the company, so we have patents filed already. One of them is granted, and we have 2 components. So the one is the experimental part, which is the way that we measure, that we manage, and that we developed to measure this genes or the activity of these genes out of the saliva is different than what was already existing. And then the way that we analyze the things is different than what was already existing. So there is an experimental part and a computational part. And together, they make the product that we offer. The machines that we use, that we haven't developed. The machines already exist. We buy them.
So your product is a software?
Our product is a software and a hardware, and the hardware part is the lab part. It's an experimental protocol. Yeah.
And so that means, I would assume clinics could buy a product in order to, but by the way, it only makes sense for clinics who have oncologist stations to really, have them, and then they get the little piece of hardware in there, and then they put the software on their analyzers on the computers as well.
So the idea is different. The idea is, so the company is called TimeTeller, and we sell this TimeTeller kit. So the idea would be you buy the TimeTeller kit, you spit, and you send us back the samples to the lab. We then do the analysis and we send you back the result. That's the idea, not that you install the whole thing. That would be more complicated because you do need personnel that has a certain experience or a certain knowledge to be able to do the different parts of it. Yeah.
I see. And I think we now learned quite a lot of stuff about our circadian rhythm when we should do strength and endurance training, and that most people doing it wrong. But I had actually prepared like a dozen questions for you. I didn't ask any, and we are already running more than 30 minutes of our recording time. But
let me just say a little bit something very quickly, just because you used the word wrong. Yeah. So people should not think that they are doing sports at the wrong time. So I would still argue you better do it whenever than not do it at all. Of course, if you do it very late, that will disturb your sleep. That's not such a good idea. Yeah. So don't start jogging at 10 in the night or so. But apart from that, everything is fine. Now, the difference in these times, it will have a difference in your performance. So if you would be a professional athlete and you want to go to the Olympics, you may really, really, really want to know, because maybe you want to train a lot at this optimal time. It might help you to develop even more and to get the extra seconds. It might, yeah. But that's the idea. The performance is even better. So therefore your body has more from it.
I see. I'm still doing it wrong anyways. Even though
because you don't do it at all.
I'll never attend Olympic Games. Maybe as one of the people in front of the curling curl, brushing the ice or something. That's a place I could imagine myself at the Olympics. But as lifeguard during the swim events. Anyway, that by the way, I'm not qualified as a lifeguard.
Okay.
That was a totally fascinating conversation, and we were running. When we would start now with the question, it would go into hours of interview, and I don't think we can do that here. Hopefully, I have you back sometime down the road. I would like to close our little interview here. Everybody who'd like to learn more about TimeTeller, go down here in the show notes. There will be a link to your LinkedIn profile as well as to the company website. I would like to close with the 3 questions. Number 1, We do know we're a global top 60 science podcast in the world, according to Chartable. There are a lot of men and women and all the other sexes listening to this, maybe in their laboratory. What recommendation would you have for them if they're currently in the laboratory doing the research and want to start a company?
So if that's what I thought, you were going to ask me something else, but okay, that's also fine. Then I would say you should, if you want to start a company, then think very well what is the product that you want to develop, and watch out that you do not publish something before. Because if you publish, then you cannot have a patent. If you cannot have a patent, then you have a problem to find investment and to develop the product. So that's one thing. However, you can publish after. That's what we have done. So we still want to drive science further, and we publish everything we develop. So the other thing you should watch out, or you should pay attention, is, does your university offer a program to support something like this? And currently, many universities, in particular medical universities actually, are offering such programs. And this is very, very helpful. Not just the money, but also the expertise which is associated to such programs.
I see. Yeah, that as we said, that takes a lot of special know-how. My question would be, what other question did you expect I would ask you?
I thought you were going to tell me, because you started to say people that work in the lab, what should they think about their circadian rhythms? And I was going to tell them, look, if in 2 consecutive days you don't have the same results in your experiments, then think about it if maybe in one day you did it in the morning and in the other day you did it in the afternoon. Because maybe you were measuring things at a different time, and that's why they were behaving differently.
Mm-hmm. Okay. And the other 2 questions are you open to talk to new investors?
Oh, yes, of course. Of course. In particular, and I mean, I'm not sure if I should maybe then say this, but I mean, I would really like to talk to investors that share a vision with us. So I'm saying this because sometimes you have the impression people don't care so much. It's just about putting money in and getting money out. And I would really, really like to talk to investors that say, we also want to participate on this because we think it will help a lot of people.
Mm-hmm. That's pretty good. And do you also look for talented people?
Always.
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 We link your website down here. I'm not sure. I just while you were talking, I linked your R&D page where if people scroll down, they can find all the papers you've published there. And I'll link, of course, your career website here where people may apply if they find it interesting and want to help cancer therapy.
Yes, just send me an email. We're always looking for talented scientists, both in the computational field as well as in the experimental field. And with us, you have the chance that you can do your research, but you can also try to develop it in something that you see the use of it on real people.
Angela, thank you very much. It was a very interesting interview. We're now talking for almost 40 minutes, even though it completely went off the race.
And you did not even ask me
did.
about Relógio. That surprised me now.
Sorry? I didn't ask you about
Relógio, because it means clock when you started to speak Portuguese.
Yeah. No, I didn't. I only have like a handful of words I can tell in Portuguese. Obrigado, bom dia, and I think that's almost
it. Relógio means clock.
Oh, relógio means clock. That is actually a good closing word here in terms of our interview. Angela, thank you very much. It was a pleasure talking to you, and hopefully to have you back in some time.
Thank you.
Have a good day. Bye-bye.
You as well. Bye.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.